Okay, so you've watched the video that was your homework last night. It's about 12 minutes long. So I got about a 20-minute at the most lesson today. And then, of course, you'll have some time to work on the assignment. And I don't think you'll have any trouble with this, especially as good as I felt like you guys picked up what we did yesterday. Um, Today will be pretty easy. I want to show you guys something because what we're talking about today is this idea of the remainder theorem. So I'm going to make a quick connection, and then um, you're going to see how we can do synthetic division, and it's probably, in my opinion, even easier than using our calculators sometimes, especially if you have to think and you have to do some math in your own head. In my opinion, synthetic division is almost faster than even typing it into your calculator. But I want to make the connection so if you're ever dealing with a situation where you don't have a calculator, you're not stuck because you know you can do this. So here's the point. If you look at this very first problem, we've got a function x cubed plus 9x squared plus 22x minus 1. And A says, hey, find f of negative 1. Well, we've done this before. Remember, if our problem says f of negative 1, we literally just go to our function, and everywhere we see x, we plug in negative 1. Now, the only thing you could ever screw up with that is when you have that negative 1 raised to an even power. I told you that it's imperative in those situations that you put that negative 1 in parentheses. So, in my opinion, just every time you enter it for x, just to be cautious, just to make sure you don't make a silly mistake, let's go ahead and type in negative 1 in parentheses. So we start with that first one, x cubed. So in parentheses, negative 1, close parentheses, cubed, plus 9, open parentheses, negative 1, and then close parentheses, squared, plus 22, open parentheses, negative 1, close parentheses, minus 1. All I've done is I've literally, every time I see x, I'm plugging negative 1 directly into it. See, what happens is it evaluates that function, treating x as if it were negative 1. So basically, you just go to your calculator, you type this in, and it spits out the number negative 15. And in a way, that's kind of like an ordered pair. When your x value is negative 1, the function's output, y, equals negative 15. Okay, it's like they are paired up. I couldn't plug negative 1 into this function and get any other value other than negative 15. That's what it has to spit out. That's the rule. Okay? So here's the deal. Yesterday, we said, hey, what if I divided this by x plus 1? Now remember, if we're dividing it by x plus 1, essentially, what are we putting in the box? We're putting negative 1. Remember, you put x plus 1 equal to 0 and you solve it in your head, and it's negative 1. Negative 1 goes in the box. So if I use synthetic division to divide this, remember, you start with your x cubed. This is what we're dividing. This is our dividend. X cubed is my biggest coefficient, or exponent, and its coefficient is 1. Then we work our way down. We did this yesterday. X squared's coefficient, 9. X's coefficient, 22. All the way down to our constant, which is negative 1. Again, I'm not showing you anything new. This is literally what we did yesterday. We bring this 1 down, and we start combining until the end. Now, guess what? You're going to see that here in just a minute, there is a similarity that occurs when we do synthetic division with the factor x plus 1, the value negative 1. The same value that we plugged into our function a second ago. Watch what happens. Negative 1 times 1 is negative 1. 9 minus 1 is 8. Negative 1 times 8 is negative 8. 22 minus 8 is 14. And negative 1 times 14 is negative 14. Now look, what does negative 1 minus 14 equal? Negative 15. You see, the remainder, when we do synthetic division with the value negative 1, it gives me the exact same solution that we got when we plugged negative 1 into that function. And that's not a coincidence, okay? That happens every time. Look, grab your calculator real quick and do this next one. Every time I see x here, I'm going to plug it I'm going to plug in 4. So I'm going to go 2 times 4 raised to the 4th power in my calculator minus 30 times 4 squared plus 2 times 4 minus 17. And I'm just going to let the calculator do all the work. Okay, I'm not going to try to do that in my head. 4 to the 4th power gets pretty big. I mean, that's a pretty decent sized number. But when you put all that together, the answer was 23. Now, you couldn't have done that very well in your head. Okay, think about it. 4 to the 4th power means 4 times 4, 16 times 4, 64 times 4. I mean, you're starting to get into some math that's pretty big at that point. So instead of doing that, watch what you can do using synthetic division. Remember, if we divide by x minus 4, that means 4 goes in the box, right? My x to the 4th coefficient is 2. Then we work our way down, right? What's after x to the 4th? X cubed. I don't have x cubed. 0. Then x squared. That's negative 30. Then x. That's 2. All the way down to my constant. That's negative 17. Now watch. Now sometimes this math gets a little bit big, but most of the time it's actually pretty manageable. If I bring down that 2, 4 times 2 is 8. 0 plus 8, 8. 4 times 8, 32. 32 minus 30, 2. 4 times 2, 8. 2 plus 8, 10. 4 times 10 is 40. And 40 minus 17, sure enough, is a remainder of 23. Same value. And in this math, I can do all that math pretty much in my head. This would have been hard. So what if I didn't have a calculator? If I didn't have a calculator, this, even though it's something that's simple, like just in, like it's the idea of that, that's easy. But actually doing some of that multiplication, it's pretty tricky. This was pretty simple. I knocked it out with synthetic division, and sure enough, the remainder is my solution. Okay? That's my solution if I were to plug 4 in. So that's exactly what the remainder says. It says, if a polynomial function f of x is divided by x minus a, then the remainder of doing that synthetic division, the remainder is f of a. Okay? The remainder is the solution of f of a. So we're going to use synthetic division to evaluate a function, and that is called synthetic substitution. Synthetic substitution. Okay, not a crazy thing to have to memorize. It's just called synthetic substitution. We use synthetic division to evaluate a function. So for example, look at 3. They want me to evaluate this function, x cubed minus 13x squared plus 39x minus 4, with the value of x, 5. Now look, this is not saying divide by 5. It's not saying divide by x minus 5. It's just giving me the value that I put inside my box. You don't have to change the sign here. It's not like it was up here when we had x minus 4 and we had to change that to 4. Or we had x plus 1 right here and we had to change it to negative 1. They're literally giving me the number to put in the box. Okay? So x cubed has a coefficient of 1. X squared, negative 13. X, 39. All the way down to my constant, negative 4. I'm going to bring down 1, and I start my synthetic division, just like we did the other day. 5 times 1 is 5. 5 minus 13 is negative 8. 5 times negative 8, negative 40. Negative 40 plus 39, or 39 minus 40 is negative 1. 5 times negative 1 is negative 5. And negative 4 minus 5 is negative 9. So f, look, this is how we write this answer. F of 5 equals negative 9. That's exactly what we get. I promise. You can try it on your calculator if you want. If you go plug 5 cubed minus 13 times 5 squared plus 39 times 5 minus 4, I promise you get negative 9. But we use synthetic substitution to solve. So again, watch how fast. I want to check 10. My x cubed term is my biggest one. It has a coefficient of 1. X squared has a coefficient of negative 10. X is not there, so 0. All the way down to my constant, negative 4. Bring down that first term 1, and we start multiplying. 10 times 1, 10. 10 minus 1, 0. 10 times 0, 0. 0 plus 0, 0. 10 times 0, 0. Negative 4 plus 0 is negative 4. My remainder is negative 4. Therefore, f of 10 equals negative 4. Done. Okay? That is called synthetic substitution. It's real simple. Okay, if you were able to do what we did yesterday, it's just taking synthetic division and it's given me another ability to solve without having to do a lot of difficult math or even having to have a calculator. So you have a problem like this. A bicycle manufacturer determines that the profit per bicycle when producing X bicycles per day is given by this formula. Use the remainder theorem to find the profit by bicycle when 4 are produced each day. So we're literally just going to type 4 in here. We're going to take all of our values, remember, from my biggest term all the way down to my constant, which you don't see here. The x to the fourth coefficient is negative 1. X cubed, 7. X squared, negative 5. X, positive 1. All the way down to my constant, which is not there. You have to include it, guys. It's missing. It's still important in this process, so you have to have a 0 for your constant. Now we bring down the negative 1, and here we go. 4 times negative 1 is negative 4. 7 minus 4 is 3. 4 times 3 is 12. 12 minus 5 is 7. 4 times 7 is 28. 1 plus 28 is 29. And you might finally get to a number here that you need a calculator. 29 times 4 is 116. And 0 plus 116 is 116 as a remainder. What does that mean? That means that the profit per bicycle, if you could start making 4 per day, would be $116. And there you go. That's how it works, guys. Real simple application. So that leads us back to something that we did talk about yesterday. And I don't have to spend a lot of time on this because, like I said, we did this yesterday. Don't forget, we also can see this as a factor theorem or use this as a factor theorem. If I want to determine if a certain polynomial is a factor, the remainder, like we said yesterday, has to be 0. So we do the same thing. Now this time, there's a little difference than what we just did because they're giving it to me as a factor. When they give it to me as a factor, then yes, I have to set that equal to 0 in my brain and solve it. So 4 goes down as my value in my box that we're going to check. Then we start working x squared, coefficient is 1, x is negative 16, all the way down to my constant 48. Now again, remember, what we're looking for here is the remainder is 0. Then I know it's a factor. So we bring that 1 down. 4 times 1 is 4. 4 minus 16 is negative 12. And 4 times negative 12, sure enough, is negative 48. So yep, 48 minus 48, 0. So then, yes, x minus 4 is a factor of x squared minus 16x plus 48. We talked about that yesterday, okay? So, again, this is real simple. I'm going to do one more that's a no, just to remind you. So this one, x plus 8, I'm going to put negative 8 in the box. X cubed, my biggest coefficient, or exponent, so its coefficient is 1. There is no x squared, so 0. Then x, negative 1, all the way down to 505. So we're going to get some pretty big numbers here probably. Let's see. We bring down the 1. Negative 8 times 1, negative 8. 0 minus 8, negative 8. Negative 8 times negative 8, 64. 64 minus 1, 63. And sure enough, you're probably going to need your calculator for that number. But negative 8 times 63 is negative 504. So close. But what is 505 minus 504? 1. It's not 0. So guys, is x plus 8 a factor? No, it is not. So we talked about that yesterday. So all of this stuff is just repetitive. So there you have it. Another way you can use synthetic division. It's very simple. So your homework tonight is going to not only deal with it from this perspective of evaluating a function, but you're also going to have some additional questions over this factor theorem. So I want you to get, if you don't have this paper already, it's headed your direction. I want you to do all 8 questions. That's not that hard. You, even after watching both videos, that should be about 28 to 30 minutes. You should still have about 15 minutes of class left, and you shouldn't have a hard time finishing this up. This homework assignment, it looks as if it really is just the remainder theorem, not the factor. So again, we tested that, worked on that last night. So today you do the remainder theorem. Okay, easy stuff. Again, sorry I'm not here today, but I promise you I'll be back, well, tomorrow, but I won't see you. But I will be back on Friday. And I shouldn't be missing too many more days. This appointment was one I couldn't avoid. So y'all have a great rest of your Wednesday. I'll see you in class on Friday.